Okay, I've gotten the word. It's time to get going. This is Jon Toigo. Welcome, everybody, and good morning, good afternoon, good evening, wherever you happen to be in the wonderful world of the Internet. Thank you all for taking time from your busy schedules today to spend a few minutes talking about trends and technologies in data storage. I wanted to use this time first to consider storage within a more holistic context, which is to say that what's happening in business IT generally. Nobody wants to talk about storage per se, in my experience. They want to understand what's happening in business and what's going on with the technology that can be brought to bear to help meet business objectives. So rather than just talking about a specific rarefied technology, I want to focus instead on a broader context. Okay, well, we begin with 2014. Data continues to amass. How much per year is data growing? I guess that's anybody's guess. In 2011, IDC found that there was about 21.2 exabytes of external disk storage capacity deployed worldwide, and they estimated that that was going to grow at about 40% per year in response to capacity demands, aka data growth. However, last summer, they changed their projection and stated that in highly virtualized server environments, capacity demand was going to grow at 300% per year. And this was a function, they said, of the need to break up storage networks and return to sort of a direct attachment model for storage, where the arrays and the disk are directly attached to each and every server, and then data gets replicated behind every server back and forth in order to facilitate workload migration from one machine to another. So that was going to spike our data growth to 300% per annum. And then, not to be outdone by their little cousin, Gartner said a couple of weeks later that no, we were looking at 650% growth in storage capacity requirements every year, especially when you calculate in data protection copies and all of the analog data that, of course, is being converted to digital these days. So who cares? Who's right? I don't know, and I don't think you know. In fact, most companies I go to, nobody knows how fast data is growing. They only know how much more storage they're adding year over year. And that's a different question, of course, but it's certainly a minor one compared to the issues that most of us confront on a day-to-day basis. We need to make sure that we have enough capacity in our storage pool, that we don't run out of capacity behind our applications, or when users go to save a file, they don't receive a disk full error message. And then, of course, we need to make sure that we've got sufficient speeds and feeds, interconnections between applications and end users, and the stored data that that will facilitate data access, so that wherever a user goes. And that's becoming more important as we enter an era of mobility. And then, of course, you need to provide adequate services for protecting, securing, and retaining your data assets for as long as they're needed, or as long as the law requires. Oh, and of course, all this needs to be done against the backdrop of what's likely to be an ever shrinking budget for doing anything at all. So our challenges are practical and pragmatic, and I would say rather daunting. And frankly, the reason why we're finding that there is a greater need for storage but a less of a budget for it is that storage, we've suddenly discovered, isn't as cheap as everybody thought. Depending on the analyst you read, storage now accounts for between 33 and 70% of all IT hardware spending worldwide. So it's roughly a third in smaller shops, and as much as 70% in shops that are amassing large amounts of data. And that isn't very expensive. That isn't very cheap at all, whether you're talking in terms of dollars or drachma. Unlike a few years ago, disk isn't showing the price reductions of 50% per every 12 months. We used to see disk, we could buy the same capacity next year for half as much as we paid for it this year. That trend has stopped. Over the last couple of years, we've seen it kind of stabilize and even go backwards a little bit. So it's taking a lot longer for disk level price reductions to be realized at 50% per year. And of course, capacity improvements were occurring soaring at 100% every 18 months from about 1982 to probably about middle of the first decade of the 2000s. That has also ceased to be the case. We are seeing some advances in capacity, but not nearly at the clip that we were seeing before. And it wasn't like these savings were being passed on to consumers anyway. I mean, even with those great economies in disk drives, hardware vendors still found ways to kind of jack up the price of a disk array by at least 120% per year, usually by adding a lot of value-add software. So the bottom line is storage costs are not inconsequential, and to senior management and their bean counters, storage is starting to look a lot like a nail in search of a cost-cutting hammer. So the classical solution to these problems have been to find ways to reduce storage costs. Have basically come down to an implementation of some sort of storage tiering. That entails the use of different media with different cost and performance characteristics to host different data that, of course, has different access requirements. All data is not the same. Now, in this analysis, which is represented here, it's drawn from the work of a great analyst by the name of Fred Moore over at Horizon Information Strategies. And according to Fred, we see that, look at the very bottom, what we call Tier 0. Basically, Tier 0 usually accounts for a very small amount of our storage. Tier 0 are your memories and your solid-state devices, your SSDs, your disk made out of memory components. Usually you store between 1% and 3% of your data in memory, especially the I/O-intensive stuff that's response time critical. And that becomes Tier 0. We're looking at a price point there of between $50 and $100 a gigabyte to store data. So it's a very expensive but extremely high-speed solution for data storage. Now, generally, Tier 0 data doesn't stay there very long. As soon as access frequency to the data that's there begins to diminish, we usually push it out to Tier 1 storage. Now, what is Tier 1 storage? Usually comprises fast magnetic disk arrays, but usually using disks that have very low capacity compared to very high speed. About 12 to 20%, according to Fred, of all of our data resides on this tier in a well-disciplined tiered storage environment. So this is your mission-critical stuff, your transaction-oriented processes, your revenue-generating application data, that sort of thing. Now, actually, this data becomes less and less frequently accessed, and we need to migrate that to less expensive storage. So in a lot of companies, we have a Tier 2, which is also disk, but it's SATA drives. They're a little slower and much more capacious. Their price point is different from the Tier 1 stuff, which is between $7 and $20 a gig. Tier 2 SATA drives are about $1 to $8 a gigabyte. And according to Fred, roughly 20 to 25% of all the data is stored on these, what he calls mid-range arrays that feature SAS and SATA drives. This is vital data. It's sensitive. It's certainly important to the business, but it's data that isn't being accessed nearly as frequently as it was when it was on Tier 1 or Tier 0. And then finally, in a well-disciplined environment, we move to data from Tier 2 down to Tier 3. This is when access frequency has dropped very, very significantly, or we've got fixed content, data that is accessed semi-frequently, but it never changes. So it doesn't need to be stored on storage media that facilitates rapid editing and reconfiguration of the data itself. We're talking about archive data, compliance data, reference data in many cases, and of course Tier 3 is the domain of tape. Which means that our cost is very low, between 20 cents and $2 a gigabyte to store data in these repositories. And, of course, the speeds and feeds, depending on how you want to measure it, are appropriate to data that's accessed at the rate that kind of data, archival data, is accessed, which means not nearly as frequently as perhaps the accesses to high transaction processing data in Tier 1 or Tier 0. So anyway, between 40 and 60% of a company's data in a well-groomed environment resides on Tier 3. That flies in the face, of course, of a lot of analyst prognostications about the death of tape. The fact is, tape has never slowed down, and in fact is showing signs of a renaissance right now in terms of its adoption as a major hedge against the rising cost of storage, and as a means to facilitate hierarchical storage management using storage tiers. Now, the impact of tiering, just to give you a sense of what the impact would be, when you look at how this all shapes up for, say, a 100 terabyte storage environment. If we use only Tier 1 and 2, that's disk for everything, Tier 1 fast disk and Tier 2 slow disk. For 100 terabytes, you're looking at about $765,000 a year. That's your cost of ownership on an annualized basis. This, again, comes from Fred Moore's analysis, which is spot on. I've done these reviews for various companies who are clients of mine, and we find that it's roughly in this neighborhood, depending on whose brand name is on the box. Now, if you add in the tape tier, you drop that price by almost half to about $359,000 for 100 terabytes of storage. That's assuming that you're putting 40 to 60% of that the older data that's gone to sleep or archival quality data out onto tape instead of loading it up on spinning rust. And then finally, if you add in the Tier 0, you want to be the first kid on your block to have a flash array, and you're storing 1 to 10% of your data there, you do increase the price a little bit, but it's still substantially less than using disk for everything. We're looking at $482,000 in that model. So as you can see, tiering is kind of a good approach to bending the storage cost curve. And tape, of course, plays a pivotal role in keeping storage costs grounded in reality for most companies. Now, if you're tracking with me so far, you probably have heard some of this before. Maybe it's resonating with you, or maybe you haven't thought about it recently because you've read so many analysts that were dissing tape over the years. They've all come to see the light now. The fact is, there's only so much fun you can have in the shallow end of the pool. So, we have to think about deeper storage that is important for data storage requirements just as much as your fast, shallow storage is the deep storage that has high capacity and low cost and can store an awful lot of business data. Now, there are many ways to leverage that deep storage, if you will, that archival storage. We've talked about tiered storage as a mechanism for hosting the data on the appropriate type of media. There's also increasingly a way to tie our storage or our data migration into the deep storage end of the pool directly to the workflow. I want to spend a little bit of time talking about that because it makes things a little simpler for some of us. I mean, when you think about it, a lot of people are afraid of doing tiered storage. They're afraid of not only HSM is kind of the easy peasy approach to it. With traditional tiering and hierarchical storage management, or HSM, data is written to primary storage and then it's subsequently migrated to other tiers based on policies that are usually somewhat less granular in nature than maybe we would want. HSM migration is usually just keyed to data access frequency and change frequency and that sort of thing, things that are stored in the metadata associated with a piece of data. So we know the date last accessed, the date last modified, and if that becomes a protracted thing, we're not accessing that data very often or we're not modifying that data at all, then it becomes a candidate suitable for migration to lower tiers. Now, sort of the ultimate expression of HSM is something that a couple years ago they were referring to as DLM, Data Lifecycle Management, or ILM, Information Lifecycle Management. We all soured on it because there were a couple of vendors out there trying to sell it like it was a product, when in fact it's more of a concept. They were selling you a component to assist with this process, but they weren't giving you anything to help you with the heavy lifting. Actually, Information Lifecycle Management says that you classify your data in advance so you know what you're going to move. And then you classify all your storage targets based on their price and their performance and their accessibility and other factors, so you know where the targets are that you can move the data to. And then you need some sort of a policy engine, usually a piece of software that determines what the pattern will be for data movement of a particular class from one tier of storage to another, and what triggers those moves. And then you need the actual physical capability, the software that moves the data itself. Those are the four components of ILM or DLM. And the problem was that ILM got kind of a bad rap because the vendors who were promoting it in the market were only selling number 4 on this list, the data mover. And they were leaving all the heavy lifting of figuring out what kind of data you have and what kind of storage you have and where you're going to move it to, and coming up with some cobble of a policy engine. They were leaving that all up to the consumer. So we all went down that path, and many people were very disappointed with the results. Now, that explains why a lot of folks are a little reluctant to dive in to this whole idea of data management as a component of storage capacity constraint. However, I'm here to tell you that there are a couple of changes that you should be aware of. First of all, we're able to tie our data movement directly into workflow now in a lot of vertical industries, sort of like one of these complex water slides that seem to be popping up all along the side major highways whenever I have my kids in the car. In reality, it kind of looks like this. Imagine that you've got production systems that are generating data in the form of files or objects, which are about 55% of the data that's being created now are in the form of files or objects, and it gets written to a disk target. At the same time, in a process called copy during write, we're now able to write that to a file system that lives on tape. There are many of these, but the one that's gained a lot of popularity recently is a recent innovation by IBM called Linear Tape File System, LTFS, which enables your tape library to serve as sort of a NAS on steroids, a file server in the extreme. So basically you're using very inexpensive media, and you're storing a copy of those files or objects in this alternative platform very inexpensively. So you got a copy on the disk, and then you've got some retention rules, and you've got a copy on the tape, and over a period of time, when the retention rules are met, you can eliminate the copy that you have on disk, and it already exists in the archive repository. Fundamentally, that's what we're talking about when you hear the expression active archive. It's the idea that we're maintaining an active second redundant copy of the data, which, by the way, is also useful if you need to restore the data after a data deletion event. And we're basically able to take that and leverage it as an alternative hosting platform for data once the data goes to sleep and folks aren't accessing it very frequently. Traditional archiving, it's a form of deep storage. Now, the problem is that a lot of folks are still a little bit of they have a little bit of concern, because it sends chills up your spines of a storage administrator if you're trying to think of, well, how do I integrate this into the process, make sure those retention rules are applied correctly, et cetera. Well, the good news is that before you jump into the deep end and you get very concerned about whether you're going to be able to swim or not in that end of the pool, along comes a company like SpectraLogic with an appliance. This reason why they engage me is because I'm pretty excited about what I've seen in their most recent announcements around a product that they're calling Black Pearl. It's a solution for deep storage. I'm not going to belabor it. I'll let them talk about it. But fact is that, like we saw before, you've got production data, files or objects, and they may be written to disk. And then you also have your tape library, which is going to store a redundant copy. But to get it over there, they insert a server, what they call the Black Pearl server. And the server operates LTFS, which is the ability to migrate the data into a file system. And it also leverages a W3C standard REST-based protocol. It's patterned on Amazon Web Services, their S3 protocol. They call it DS3 for Deep Storage 3. And it's a protocol that runs over any network interconnect, and it allows you to migrate directly from the application. Many of the applications that are out there for things like video editing or human genome processing or what we call long block files. It allows you to migrate this data over into a server that quickly caches it and then does whatever voodoo is required in order to move it via LTFS into the tape library, so you don't have to get involved in that process. Now I'm gonna go into this in a little more detail. That was kind of a very surface level treatment, but the fact is that what it does is it kind of allows us to attach directly into the workflow of the application itself. We're seeing this again in broadcast and media, in audio video post-production. What they do is they work on a piece of video, and then after they're finished editing that video, it's pretty much not going to change, and they want to store it out onto the archival repository as quickly as possible, because these are very large files. And you can actually hook into some of these video editing systems now directly with this protocol and migrate that data directly out onto tape without having to go through a lot of manual processing in order to get it there. Same is true with geophysical study data, the telemetry that you take when you're doing oil and gas drilling, or sonar testing to see where those pockets might be, telemetry from look-down satellites, video from drones and security and surveillance, et cetera. Anything that's a long block file. And what's really cool is that they've sort of introduced a solution that leverages content as objects. So you can take a bunch of little files, which LTFS is really not optimized for. LTFS works best with long block files. You take a whole bunch of little files in a folder, say a web server file system, which is actually very flat, and there are a whole bunch of little files to describe one object. And you save that as an object, which then becomes very large because of the compilation of many little files. And the Black Pearl server will facilitate the movement of that content, that object content, directly from where you're copying it from over to tape using LTFS. So it's kind of a way to optimize LTFS, but it's also a way to make it kind of drool-proof for the operator. He no longer needs to be an expert in all these rarefied technologies that enable data to be written from an application over to multiple targets, one of which happens to be tape. I think that it's a real boon. I think that it's something that it also, by the way, provides a location where you can store all your retention rules and basically apply those as needed in order to migrate the data in accordance with the proper triggers. Now, this is essentially what SpectraLogic is proposing with their latest Black Pearl deep storage solution. And I don't want to steal their thunder. Hopefully, in our question and answer, they'll get a chance to go into a little greater detail on the specifications of their appliance and their protocol. Now, of course, even with easily deployed appliance that plugs right into our application workflow, there may still be challenges to implementing a deep storage solution. For one thing, we keep hearing about all the silicon that people want to deploy in their data center, that flash memories will soon overtake all other forms of storage, sending disk and tape into the dustbin of history for the same reason that, when I hear this, I have to laugh, because I've been hearing that tape was dead for years and years and years, and it most certainly is not. I kind of envision that in the future, we need to stop listening to the marketecture and get with what we already intuitively know to be true, which is there's going to be a diversity of storage. We're going to have some memory-based storage. We're going to have disk-based storage. We're going to have tape-based storage for the foreseeable future. And that the storage diversity is actually a good thing. It's a source of resiliency and cost efficiency in our storage infrastructure. Now, second issue that I wanted to quickly touch on is that a lot of people say, well, I don't need to understand anything about these newfangled approaches for containing capacity requirements, because we've got the great disk drive in the sky. We're going to be able to leverage an unlimited pool of inexpensive storage capacity, out of the cloud. And that's a great idea, and if it comes to fruition, I'm all over it. However, I think, I have to be a little cautious here. For one thing, in the last year, we've seen repeated access interruptions and security breaches, even in clouds that are considered to be the most professionally run entities that are out there right now. And of course, we've seen different cloud vendors adopting different stacks of technology that are fundamentally incompatible with each other. It goes back to when I was running my first data center and I had some Microsoft and I had some Sun, and I'd call up Sun and say, look, I need to trade data between these systems. How do I do that? And they'd say, oh, that's easy. Get rid of all that Microsoft stuff. The fact is that the clouds don't necessarily interoperate with each other, so if you're trying to tie together the storage capacity of multiple clouds, you may have some trouble with that. And then, of course, we had an example this past year of one of the major players in the cloud storage business going out of business and leaving companies that had petabytes of storage there on their own, left them to their own devices to retrieve that storage in something like 10 days. There was no use of tape at that particular vendor site, so there was no way to offload petabytes of storage onto tape and to ship them out via FedEx. The fastest way to move data across a network is by carrier pigeon. So there was no way folks were going to get tens of petabytes out of their cloud service provider. We need to be aware of the fact that some of these companies that were the startups in this space maybe don't have a long lifespan, and we're putting our data at some risk by putting it there. So at a minimum, I would just recommend make sure that if you're using a cloud service that they use tape so that you can get your data back if something goes on. And finally, we have the issue of training. A lot of people come back to me and they say, we were decommissioning our tape libraries because we thought tape was on its way out and nobody's being trained to use that anymore. I've heard this over and over and over again, not just with respect to tape, but with respect to different kinds of operating systems and mainframes and everything else. The fact is that, IT has blessed us with a variety of technologies and platforms and media types and so forth. And what works for us to contain our cost and improve our efficiency and reduce our risk is something we need to dedicate the necessary resources to train people to use. The fact is we're not going to see I saw a dream presentation the other day by a cloud service provider that was trying to create what he called the Starbucks of storage, where you would just go to your storage capacity like a coffee machine, and you'd push a couple of buttons and the cup would drop down and you get just the storage you want. We haven't quite gotten to the point yet where the allocation and deallocation of those resources is that drool-proof. So there's going to be some training required, and we're going to have to get real with that and start making sure that we either develop those programs in-house or encourage local training to facilitate it. Now, with that said, with a little practice, you might be surprised by what we'll be able to achieve in deploying both traditional tiered storage and also some of this workflow integrated storage that we were talking about that leverage technologies such as the Black Pearl appliance from SpectraLogic. So, having said that, hopefully you've kept up with me on all of this. I want to turn over to our question and answer phase. Fortunately, I'm going to give my throat a rest a little bit because Molly Rector is joining us. She's the Executive Vice President of Product Management and Worldwide Marketing for SpectraLogic and a good friend of many years. And Molly, welcome to the call. I would like to, we have a few questions coming in, but I'd like to invite everybody to use their little chat question tab if they have some additional questions that they'd like to throw our way. I've gotten a few just during the time. Apparently some of you folks are already very accomplished at operating this kind of interface. So we've got a few questions in the hopper, and Molly, welcome.
Hi, John. Thank you.
Okay. Molly, let's just jump right into it so we can make the best use of everybody's time here. First question was, what is the difference between traditional tiered storage and workflow-specific archiving? Are we really talking about the same thing, a horse by another name, or are we talking about an entirely new concept for how to move data into deep storage?
I think that it's really just an optimized answer. I don't have a, approved by the book answer to that, but traditional tiered storage, really the concept of it was you move data over to less expensive, slower tiers of storage over time, and often had to move the data back up those tiers of storage as you wanted to access them. And with deep storage, workflow-specific storage, really the concept is that instead of all the files you have, whether they're big or little, and if they're email or if they're PowerPoints or big production video systems, instead of handling them all individually and in the same way, that the concept of workflow-specific archiving really is you have similar types of data that you manage in a big bucket all at once. So you have whether it's a film or it's a CAD design project, an engineering project that's been completed, and you don't need folks to have individual access to it minute by minute, day by day. You can archive it in one big collection off to deep storage, whether that's in a remote cloud, a local cloud, whatever that looks like. And the value to it is it takes an enormous amount of cost and complexity out of handling everything on a file-by-file basis, and you can really lower the cost of your long-term storage. So easier to manage, but it takes a little bit of change in mentality. Instead of thinking of accessing each file individually, you're accessing projects all at a given time.
Well, I agree with you. I think also, remember that HSM started in the mainframe space when all data was being processed through one common processor, so it was easy to establish a hierarchical model that was centrally controlled. Today, data is all over hell and half of Georgia, so our ability to wrangle all the bits and put them where they need to go becomes a slightly more daunting task, I think. And the more we can leverage things like Black Pearl that will integrate directly with a workflow, the less mistakes will be made. There have been some great questions coming in just when you were talking. Apparently, you've stimulated a lot of fired a lot of synapses in people's brains here. One person wrote in, what applications are tested with Black Pearl? Are there any specific applications that Black Pearl will tie into currently?
Sure, that's a really good question, and the answer to that is Black Pearl offers a very simple interface that's very much like S3. So it's actually, we've added a couple of commands to the S3 protocol to make them optimized for tape. So being able to move large chunks of files to tape at a given time to be able to stream the tape media, and also to take advantage of or to optimize for the time it takes to recall a file from a tape. So if it takes 60 seconds for a tape to mount and stream data back, those extra commands we added to the S3 protocol take care of that issue. So any application out there that can write to S3, and there's hundreds of thousands of them, can write directly to Black Pearl. If they add those extra commands to optimize for tape, they'll get much better performance. We're also looking at, so there's lots of clients out there that end users, software vendors have already written to be able to write to S3. We also have in our ISV technology software partner infrastructure quite a few partners who are writing a plugin to Black Pearl as well. So for example, in the media and entertainment space, there's asset management software packages that do all the clever things around how you can recognize faces in a video and tag which driver was associated to which car in a NASCAR race, those types of things. And those asset managers are also writing plugins to tie to Black Pearl to be able to use that as a tier of storage. So anyone who can write a RESTful S3 application can very easily use Black Pearl. In our developers community, we have sample code and sample clients up there as well, and it's being supported in a lot of the upstream applications as well.
Well, that actually, there's one specific question somebody offered here was is it compatible with Commvault?
So at this point, we haven't done any integration with Commvault specifically. I know that Commvault does have an ability to export to the cloud, and so that would be something that would make sense for us on a business development perspective to work on, but it's not something we've worked with them at this point with.
Okay. Some smart Alex said, what happened to paper punch tape? I'm going to slap somebody. Fred Moore happens to be in the audience today. I'm delighted. Fred, welcome.
Hi, Fred.
And he says tape has made major strides in reliability, throughput, capacity, and cost, but many users still don't like tape. Do you see tape gaining mind share in the near future? And what drives this change if it transpires? Will Black Pearl and your concept of deep storage help to establish yet another application for tape?
Yeah, I think that in the last decade there's been a big pendulum swing on the use of tape, that tape was associated by and large with either off-site disaster recovery or with backup. And as deduplication came in and made sense as a tier in the disk-to-disk to tape backup strategy, a lot of people thought, well, if tape is synonymous with backup, there's really not much use for it anymore now that I can dedupe and replicate and things like that. And what the introduction of Black Pearl, Active Archive, all the applications that John has been talking about for tape, it's just another storage medium. You don't think of it, you shouldn't be thinking about it as backup media. It's a storage medium that has certain cost, power, and access attributes that make a lot of sense for infrequently accessed data. And as users start to think about how do I manage hundreds of terabytes into petabytes of primary data, of which only a small percentage of it is accessed on a daily basis, using tape as a storage medium for their primary data, granted it's their older, less accessed data, is really what's the resurgence in tape and why people are using it. There's lots and lots of customers out there that I've worked with in the last couple of years that are dealing with the problems of their data centers out of power. They have to figure out how can they manage more data with the same amount of power. They're looking at footprint limitations on how much space they can use in the data center. So the use of tape for storage of content versus for backup is really fitting really well with the limitations people have in the data center. And so there definitely is a resurgence, and it's in a different use case, and that's what Black Pearl is targeted towards.
Well, I'll share one example from my experience too. I have a client that's a pharmaceutical house in New England corridor, and they were told by the FDA, as everybody was, that you needed to store a near online copy of data for all clinical test trial data in case people start dropping dead from the med, and they want to be able to quickly review all clinical test trials. And the guy said, look, we've got more money than God. We own the patent on Viagra. We could go out and buy the latest and greatest disk array, but we can't get any more energy dropped into our data center. And it pushed him back into tape because now he's got a very small footprint, very low energy consumption, and extremely large capacity for storing all that clinical test trial data. And so he's in compliance, and it's not costing him an arm and a leg to do it. There is another question here that does come to an issue. Are you eating your own children? I mean, is Black Pearl a better solution than using N-tier Verde for archiving, both products from Spectralogic?
It's definitely a very different solution. That N-tier Verde is an online NFS CIFS kind of NAS solution. It has the attributes that you would expect of any NAS storage solution, that it has online immediate access to the data. It certainly is designed for longer term retention content in the way it's priced, in the way that we protect the data in the system. Black Pearl, when you move the data off of your NAS system, whether it's an N-tier or a NetApp or an Isilon, whatever your NAS storage is, when you move your data to Black Pearl, it's now stored in objects that need to be retrieved in a batch. So you move your objects and the collection of data back up to presumably your NAS system when you're going to be editing and making changes to it. So think of Black Pearl as a long-term, easy-to-search retention system, but when you're actually working with the data, you'll put it back up into your NAS, whether that's your Verde or some other vendor solution.
Okay, and another question that's related to that is, does Black Pearl handle or manage retention policies directly, or do I need to buy some sort of archiving software to go with it?
So the management retention policies are all written into the client. There's the DS3 client or the S3 client that as data is moved from the original environment into the Black Pearl, you can specify how many copies of the data you want to keep, what's the retention of those copies of data, are they in the same system, a separate system. So that's all built into the DS3 client that moves the data into the Black Pearl.
Okay, somebody asked a very much an on-point question, which is, has any user training been developed to help users classify their data and to encourage the use of some sort of active archiving or something like Black Pearl to leverage LTFS?
Yeah, there's a couple of different answers from that, not all specific to Black Pearl, but there's the Active Archive Alliance, which is a multi-vendor organization that's been around for about 4 years now that has developed lots of best practices. We actually have an administrator training on how to architect and implement an active archive that's really great. And that's designed around folks who are using other applications, an archive-specific application to be able to do their content archiving. So there's great certifications built in there. Specific to Spectralogic and the Black Pearl offering, we just went general availability with this past month. We do have a developer's website that has code samples, the APIs, the development kits, but as far as specific training for a user on how to classify the data, that's not something we've created yet at Spectra.
Okay. I'd put in a plug for my own company, but I don't want to. However, I have been asked the question directly. It says, what is your take on tiering to cloud storage, especially public cloud? I think there are some great cloud storage offerings that have come to pass recently. Permavault is one. Deternity is another. They're tape-based in the cloud, and they're leveraging technologies like LTFS, like very high-capacity tape, as the modality for storing data. I think that's critically important. I mean, when you look at speeds and feeds of networks today, even with the fastest network that I might be able to get my hands on, say an OC 192 or something, it takes about 4 hours for every 10 terabytes of data that you're going to transfer under ideal conditions. If you're putting petabytes of data up in a cloud, you're not going to get it back across the wire you put it there with. And you better have tape as your alternative transport mechanism, which is basically IPVAC, avian carrier. You know, put it all on tape and then strap it to the leg of a passenger pigeon or put it on a FedEx plane, and maybe you'll get it back in a timely way. I don't trust storage clouds that are based on any other technology but tape, or that leverage technologies to the exclusion of tape, if that makes sense. Now, let's get back to something a little more intelligent. Are there or will there be any developments with Black Pearl and the larger file system solutions like GPFS and Lustre?
Yeah, that's a great question. And we have at Spectra a couple of developers that their entire job is just to write Black Pearl clients and tying into other file systems beyond, without having to require a user to move their workflow to be able to write to a RESTful protocol. We do believe tying into the different file systems makes sense. It's a matter of prioritization and deciding whether we're going to write that client, or if an end user or customer wants to write the client, or if some kind of integrator advisor is going to write the client. So there's lots and lots of ideas of the ways to tie Black Pearl to workflows, to applications, to file systems. Specifically looking at GPFS and Lustre are things that we are looking at, but will be whether we put the resource onto developing the tie ourselves or if a client does it themselves is yet to be determined.
Well, is it meaningful at all that IBM in its latest release of Enterprise LTFS has supported GPFS? I mean, if they're already adding the integration at the LTFS level, can you not just leverage
I think
that?
It's meaningful in that the business value of tying file systems directly to any kind of storage medium, whether that's solid state, it's spinning disk, or it's tape, it's clearly the direction that users are driving the vendors to go. So I absolutely think it just shows that we're headed on the right path, and file systems being able to write directly to tape makes a ton of sense.
Yeah, actually, there was a lot of pushback on LTFS originally from my clients until they said, look, I'll go for it when GPFS is supported, because apparently that gives you file tiering. You can go from platform to platform without concerning yourself with the differences between memory versus, or solid state versus magnetic disk versus tape. And you can actually migrate much more smoothly the files from one platform to another. So having that kind of integration is apparently a very desirable thing. Another question, at what time interval, let me see if I can make sense of this, at what time interval does not often access linear tape storage need to be recopied to a different tape to ensure no loss of data during tape aging? I think that goes to the resiliency of tape, which I think on the barium ferrite stuff is now rated at about 30 years. Do you? But of course that has to do with workload. How does Spectra monitor the lifespan of tape and its usage characteristics, so I know when it would be smart for me to move data off of an existing piece of media and onto fresh media?
Yeah, the life expectancy of tape is many, many years for sure. I think issue that people have had in the past is maybe they had 1,000 tapes sitting off on a shelf somewhere, and they didn't know the quality of the data on those tapes, where with a spinning disk controlled by a RAID controller or some kind of software RAID, it's constantly checking the storage medium. The fact that tape is not constantly being checked, you can be surprised when you need the data when there's an error versus catching it just as disks go bad in a standard spinning system. How we've addressed that in all of our tape libraries, regardless if you're using Black Pearl or a backup application or an active archive application, is we have baseline data that's written to an RFID chip on each of the tape media that tells us things like the born on date, the number of times there's been an error, the number of times the data has been accessed. We also have the capability in our system to, on a scheduled basis, go back and check each of the tapes. So if you have a tape library with 1,000 tapes in it, we can have it be where every 6 months in the background, when the tape drives aren't in use, the tape library will actually go mount up the tapes, check the quality of the tapes, any errors that they have associated, and if something's wrong, make a recommendation to copy the data off of those tapes, which is very similar to what you'd expect in a disk system. You expect disks to go bad. You just expect the system to know it and be able to copy the data when the failure occurs. It's very, very similar, where we just automate that process of checking the tape instead of waiting till there's an active data retrieval occurring to go look at the tape.
So you mount the tape, you do a pass for it, read verification, and then you put it back on the shelf again? Is that what you're saying?
Exactly, exactly. And one of the clever things with Black Pearl is that if there is an error with a tape with barcode number 1, Black Pearl, because it knows exactly which files and objects are sitting on which tapes, can automatically migrate the data to a different tape without the user even having to receive a notification. If some other software application is managing the file movement or the backup file movement to the tape, we'll send a notification to the administrator so they can initiate that data copy through NetBackup, for example, so it knows where the data is. With Black Pearl, it can be done automatically.
Do you keep, obviously you're using a fairly generic server for Black Pearl. It can be implemented on a generic server, but are you using the Verde platform as the server and as a disk buffer if somebody wants to use that ahead of the tape library?
Yeah, so the currently shipping products, Black Pearl, is, like you say, it's a white box server with solid-state disk built in to be the cache. The solid-state disk collects lots of small files up into large enough files to justify streaming them off to tape. So addressing the issue John talked about earlier of tape and LTFS are designed for larger files. So we collect until we have a large enough object to move data to tape on the SSDs. And we do that for performance, that the SSD cache to Black Pearl is designed for really high performance, high-end environments. We have announced that the directional intent in 2014 is to be able to put that server on the Interior Verde as well, where really the SATA disks that are in the Interior Verde can be treated either as a cache or they can be used as your NAS storage with the ability to migrate directly to tape using similar technologies of Black Pearl. So we will have both offerings where the Black Pearl with the SSDs are designed just to be cache, not storage, where on the Interior Verde we expect the SATA disk drives will be used for storage for some amount of time, but then we can push directly to tape on the back end. And that's a 2014 product.
Another question came in from the listeners. Is Spectra planning to use Black Pearl in their public cloud storage offering?
So Spectra does not offer a public cloud offering. We're not a service provider, if that's what was meant by the question. Mm-hmm. We are talking to several of the public cloud service providers about using this technology as a back end to their storage systems, but we would be having other public cloud offerings leveraging our technology versus offering a service of our own.
Let me, I think this is a very good question. Somebody's written in, you've talked about using binary objects and files and using your repository for that purpose. Is there a use for this behind a database?
That's a good question. I think if you saw it as a use for the database, it would still be for either a copy of the database. You could do an export of the database. Perhaps it's the transaction logs that you want to keep a copy of, but you definitely wouldn't run the active database on the system. It would be used for large copies of the critical information out of the database, or if you were exporting an enormous table space out of the database but still wanted to keep track of it, you might find a use there as well.
Actually, one of my clients is looking at using an LTFS repository, but what they've done is they've implemented Storehouse's file store which takes your database, a SQL database, and creates flat files out of it. And they're still SQL searchable, but they're just files. And then now you're in a file mode again, and you can export those files over for long-term archiving if that's your druthers. So maybe look at SGI's offerings. Whoever wrote in that question, you might be able to use that software in conjunction with Black Pearl. I don't know. Okay, and we're getting close to the end of our time here, but I want to go through as many of these as I can. Are there? I heard that LTFS is only good with long block file storage. Well, that's what I said. Is that true? Talk a little bit about what you're doing in terms of, say, web server file storage, because that's a whole bunch of little files that describe a larger thing, a web page or whatever. Can you explain that?
Yeah, so from my perspective, and John, I know you know a lot about LTFS as well. The reason we use LTFS in Black Pearl is that because the Black Pearl is designed to store long-term retention data, storing it in a format that's open, readable, and self-describing makes it easier for those folks who are worried about what does it look like 10 years from now if I need to access that content, and vendors and technology have changed. So we like LTFS for the open, readable, self-describing capabilities. Tape in general, regardless if you're writing to it through TAR or LTFS or any other format, is really optimized for streaming large files of data. So once you spin up a tape drive, it takes about 55 seconds in a tape library to go get a tape, seek to a certain point on the tape, and start writing or retrieving data. Once you're doing that, that tape device can stream anywhere with uncompressed, just native data from about 140 megs a second up to close to 300 megs a second, depending on what kind of technology you use. Right. So any individual tape drive is extremely fast once you start streaming it. So you want to take advantage of, after you take those 55 seconds to mount the tape, that you actually stream a reasonable amount of data instead of one little file that only takes a millisecond to do.
Well, that's the reason why a lot of the folks who are doing the head ends on LTFS, which I would assume Black Pearl does as well, are using caching and buffering as a mechanism to expedite the read process. So when somebody requests a file, if you have a stub for that file or some small portion of the data, you can begin streaming that out off the server while you're positioning the tape in front of the read-write head, and you can pretty much mask the seek time, if you will, the aggregate seek time, which you just described, from the user's experience of the retrieve. I don't know if that's how you plan to use the product, but it's certainly a mechanism I've seen over and over again from a number of the heads that are out there that go in front of LTFS. What is your recommended maximum object size for Black Pearl? Is there a limitation on size, or either the smallest or the largest? Have you guys determined that yet through your own testing?
So there's a couple of questions embedded in there. So we don't care what the size of an object is. Those objects are put into buckets, and then the buckets are how we manage the data as it's moved to tape. The number of objects, we're still testing the limits of the system. It's very, very big, as in many billions of objects. We don't know the exact limit of the system yet. We haven't been able to test to the limit. So we certainly have been looking at data sets in the many dozens of petabytes kind of environment, and a realistic number of objects within those. And it is many billions, we know that. I'm sure there is a limit, but we don't know exactly what it is.
Well, and my final thoughts on this, I'll give you a second to respond to this, are that yours is the first marketing messaging that I've seen that's actually trying to conflate or combine the concepts and value proposition of both object storage and file storage. When you're talking about the LTFS, it's the enabling technology for deploying a file system, a self-articulating file system on tape, and then you're combining that with the content object stuff that you're seeing, especially in broadcast media and surveillance video and that sort of thing, where they use kind of a quasi file system plus database architecture for labeling all those files. Same is true in medical imaging. This is low-hanging fruit stuff, and it's a good opportunity to teach people what objects are. So but you're doing the Lord's work, because now you're going to have to take a bunch of old-fashioned storage guys like me who are used to block and file and start teaching us what objects are, right?
Yeah, absolutely. What it comes down to is lots of file systems are starting to be stretched in their performance on the number of files and the amount of data that they're storing. Object storage is a flatter system. It scales larger, and it's very, very easy to write to. So it definitely is the new paradigm that we'll be seeing in the data center over the next 5-10 years on ways to handle massive quantities of data and massive numbers of files. And it will be an education and process and how we implement it in the data center. It will take some time. The big guys, the big web guys have all adopted it. You're starting to see it in other markets as well. But it really is designed to handle the limitations that some file systems have on size, but also to just make it very simple to write in and out of storage so that you don't need several years of development on an application to manage data. It can be done quickly.
All right. Well, I greatly appreciate it, Molly. We have more questions than that coming in, but hopefully someone at your end will respond and in email to the folks whose questions we didn't have a chance to get to today.
Yeah, I'm sure we will. We'll get back to everyone.
One that maybe you just know off the top of your head, is there a size limit on a bucket in Black
No.
Pearl? Okay.
No, buckets are designed to be extremely big.
Okay, and then I'm assuming that this is handled by LTFS, but there's a valid question that I get asked a lot, which is, what if an object spans more than one tape? Can you handle that?
We can, and that's coming out in the next LTFS specification.
That's right.
So we actually have written our own capability to span tapes, and the next LTFS specification that's coming out, SNIA, is addressing that as well.
Very good. All right, and I'd like to thank Molly Rector. I thank SpectraLogic for giving me this opportunity to have this chat today, which I found very illuminating. I hope that you did as well. And I thank all of you for taking time out of your schedule today. And have a good rest of the day, and feel free to contact your SpectraLogic rep if you want to learn more about Black Pearl.
Thanks, Paul.